I'm going to create an event model, slice by slice, and then I'm going to deploy that to production without writing a single line of code. Then I'm going to go back to that model, modify it, and then I'm going to deploy that to production. Why? And this is really important. Because today there's a lot of excitement around the AI tools that can do code generation. The problem is they don't really survive beyond day zero. They give you a great prototype, but they're not really made for the long haul. And this is where Auto is different. We're not a code generation platform. We're a model automation platform. Let me show you how it works. Now, Auto is not just another diagramming tool. It's a modeling platform that comes with presets that allow you to fall into the pit of success when you're creating models. So if I come here and create a new file, and we're going to create an event model, and we'll just call this our shopping cart. And what we'll do is start with an event model over here. You can see that we have a state change by default, the starting point, where I can start with a user interface at the top here, and say this is the user swim lane. I could add another one potentially for an admin swim lane if I like. And then I can create a command over here in IO, and I can create an event. It tells me where I can and can't put stuff. So it helps me do the right thing. There's my initial state change, and then I would add a state view, which might look like this. I create a state view, I can put this way, and I can put that over there. And these are my two patterns. We also have the automation pattern and the translation pattern. We've also added a freeform in case you want to do something custom. Now notice I can also add frames within here. So let's say there are multiple events this thing emits, then I can open that up. I can put this event on here, and I can specify that this command is capable of committing multiple events. I'm going to flip over to a model that I made earlier. Here you can see the shopping cart model. We have a user that can add an item using a button. This add item command, if I open that up, you can see that I've specified the data in here. And I can flip over here to the schema. The schema is automatically computed from my data that I entered, but I can also give it hints for the code generation. So in the case of adding an item to a cart, I want it to try and load the cart if it exists, so it can add to it. But if it doesn't exist, it should create a new one. I do have the option to say create or error. That means it'll try and create it. If it's already there, it'll error out. Now, when we look at something like remove item, and I look at the data for remove item, it looks good. I look at the schema, it looks fine. But this one is load or error, because when we remove an item, we want to make sure that the cart exists before removing the item. When I get over here to the adding items, when I say something like and, it'll actually pull up all the events that exist in this model so that I can choose one of them, and then I can start to dig into the actual fields of that event, and I can give them some. In this case, we have a happy path, which just says, let's create a cart, add an item. In this case, we say, given I've created a cart, when I add an item, then the cart should be created, that's the first event, and the item should be added. It's a very happy path. When we look at the remove items, then we can see that removing an item, if we assume we've created a cart and added an item to it, when we remove that item, then I expect that cart created event to be there, item added to be there, but also an item removed event to be on top of that. And finally, all of these should go into this view cart model. When I look at this, I can see that the structure of this model, and its example structure, is that I've got a cart shape, and here we can say I've got a total price of $70.70. We have a cart item sub-entity, so that's the top-level entity, and inside it has cart items or references to cart items under the items array. And in here we can see there's item 1 and item 2. There's 2 of these at 2020, that's 40/40, and there's 1 of these at 30/30. 40/40 and 30/30 equates to 70/70. That's just an example of the data. If I flip over to the schema, it looks very much like a GraphQL schema. That's because it's based on a GraphQL schema. GraphQL does a great job of defining how data is structured. We leverage the same thing here by saying we've got fields, and this is the top-level cart object, which is of type object. That contains a cart and its float total price, and an items array called items, which contains cart item that look like this. So now let's have a look at the viewing items. Here we can see a cart was created, an item was added. Now I don't see an item removed in here, so I'm going to add that right now. I'm going to actually add another item and then remove it. So here we can say, given an item added, cart 1, 2, 3, and this is item 3, and this was worth 50. It was pants. But then what we're going to say, and that same item was removed. This is the item removed, and we'll just say we don't need the rest of those details. So here we can see we've added got quantity 2 on this one. We added the third item at 50/50. We then removed it, and so we expect that the cart should have a total price of 70/70 with the aforementioned 2 items inside of it. In Auto, your models are multimodal. which means I can click on this add item command over here, and I can see the test data, and I can also see the schema that is behind it. I can attach a design from Figma, upload it. I can see what the designs from Figma look like, and then I can attach them to specific constructs. I can take a screenshot, upload it, and then I place that on a construct. I can resize it. And what we're really doing here is having the ability to create a single source of truth around your model. I can also grab a rich text document and put it onto this UI. Say this is my doc. I'm going to get a Notion style editor for creating some rich text around the thing that I would like to talk about. Now let's enter dev mode. I'll open up the side view over here so we can see what we're looking at. From my model, I can click a button to generate the code. It starts by converting the graph of nodes and edges that we see on the right-hand side into files that we can commit to Git. If I open this up and I show you the sliced architecture of event modeling, here is the command that we're looking at over here for add item, and here it is represented as files that I can commit to Git. The importance of that is when I create an event model and I commit that, I want to make sure that not only do I get the code, but I also get the model at that point in time. We're able to go from the diagramming style of modeling into a file-based approach and back again. We also generate the code. The code here is basically the TypeScript representation in this case, but you're free to create whatever language target you want. So here is what the command looks like in terms of TypeScript. Here are the tests that were generated. And if I open up the aggregate, in this case, we decided to use an aggregate, but you don't have to. You can use a decider pattern if you like, or whatever approach you want to take. And here you can see that we've got instructions for the AI to fill in the gaps. The magic of this is that now the AI does not hallucinate as much. It's highly controlled by tests, which means that we will always be meeting the specifications. And here you can see the specification that was generated. Now these specifications are generated from what we modeled earlier. Here we have an aggregate, but the aggregate doesn't have all the information we need. We know that the model said add item can lead to any one of these three events, but we don't know exactly how it's going to get there. And that's a job for some intelligent entity to perform, human or AI. By placing the instruction set like this in a very detailed fashion, it means that the AI can really not go off the rails. And with the specifications here being executable, combining these two things along with the code gen that we have elsewhere means that you get working code every time. Now the scaffold is done. I will open up and say implement with AI. Let's see what happens. Currently, we only have placeholders for all the code. And here we can see it did an update, but the tests are failing. There are some things that aren't quite right yet. So we try again, and we'll keep repeating until all the tests pass. Now the tests are passing, we know our app is good. So let's go ahead and deploy it. We can see the application was built successfully. It's been deployed, and now I'm going to go to this endpoint. So now I'm going to query for the cart, and this cart that I'm querying for is cart 123, and it's empty as expected. I'm going to go ahead and add an item to it, and the add item parameters are cart 123, item 123. It's going to be a t-shirt that's worth $10, and we're going to have a quantity of 1. We'll add that right there. We'll go query it, and there we go. It's a total price of 10 in this cart. Let's go ahead and add another item, but this time with a different ID. So 125, and it's going to be pants worth $20. We'll add 2 of those. Let's go ahead and add that. Let's see, query the cart again. Here we can see we've got 2 of these at 20, that's 40, and this one at 10, and so the total price is 50. And we can see it's carrying out the logic exactly as we designed in the event model. I can go ahead and remove item 1, which is with this ID. So if we go to remove item 1 here with that ID, let me go ahead and file that mutation, and I'll query it, and boom, we have our 2 items, and price is 40. So the cart is working as expected. Now let me go change the model and reiterate. Here's a more complicated set of requirements that I created previously. We don't want any items with the same name. It should not allow more than 3 items. We'll re-scaffold this. And this is the most important feature because this shows that we can iterate over time. So let's go see what it's created. These are much more complicated, and we can see the additional test cases that it's put in there. Here we can see it's failing. What we sometimes find is if we can't fix them, it may be that the specifications are wrong. So we go back to the model, change the specifications, and try again. And now we can see all the tests are passing. Now that they're passing, let's deploy it. Now my API is live. Let me go check it out. We'll query the cart again. and this time it's empty. I'll add an item to it, query it. Okay, it's got my item in there. Let me try to add that same item again. It's got the same name, and my rule not to add with the same name should apply. So I'll try to add it. It says success because we said emit an error event when that happens. Now if I go back, that one event is still in there. I didn't get any more items in there. But let me change the ID of the item. So this will now be 4. We'll add the item. I'll add an ID and we'll see the third item. So now there should be 3 items in there. Oh, so there we go. Human error. Even though I changed the ID, they still had the same name. So I need to change the name as well. So I'll just call that t-shirt 1. I'll deploy that. Let's look at it to make sure it's correct. Great. So I have my 2 t-shirts. The ID is actually not the part that it cares about. It cares about more the name. That's what we specified. So I'll add that too. And let's go look now. And there are 3 items. Now the rule that I added is that it shouldn't allow more than 4 items. It shouldn't allow a 4th item. So I'm going to try and add a 4th one now. We'll just say t-shirt 5 and we'll turn this into 7. We'll do a mutation to add it. The 3rd item has not been added. So there you can see, all we had to do was change the specifications. We just had to say, here are the extra rules that we want, and here's my model. And by doing that, it updated the code in situ. We deployed that same code, and the new rules were implemented. That really is the most important feature, the ability to iterate over time. This is what turns it from a day 0 application to a day whatever you want application. Now, did I mention that everything is a file and everything can be committed? Not only has it generated the app files over here, but it's also generated all these model files. And these can all be committed together into Git. Now, the final thing to mention is how much control you have as a developer. This looks pretty opinionated, but actually it all uses something we call the Model Automation Protocol. The Model Automation Protocol allows you to pretty much customize every single aspect of what you're looking at here. From the modeling technique itself, event modeling itself is a Model Automation Protocol, but also to how the code gets generated. Here we've picked a framework, something that we call the Domain Development Kit that we developed at my consultancy that I used to run called Xolvio. And you could use anyone you like here. You could use CurrentDB, you could use Axonic, you can create your own. And then when it comes to the runtime, you're in control of that. We chose a GraphQL runtime here, but you're free to create your own. It could be REST, SOAP, RPC, anything you like. The target language can be whatever you like. We chose TypeScript, but this could be Java, Kotlin, .NET. Again, you're in full control. As a developer, you basically have 2 things to work with. The model itself, which allows you to express the requirements in the language of your map, the Model Automation Protocol, and then also the mechanisms by which you turn those models into code. You're in full control. So as you can see, Auto is not just about clicking tab, 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 tab like you might in a Copilot, nor is it about writing prompts that you just keep prompting your way through complexity. As a model automation platform, it's all about expressing your architecture as code and then using that to drive development. This is what's finally going to unlock AI's promise for enterprise-grade applications. So put your models on Auto and let's cut your development from weeks to hours.